you don't want to hope that. Alright, so here's what's going to happen. You're going to start seeing some weird functions. For instance, f of x equals square root of x plus 2. Alright, well, looks pretty harmless. Now we all know that that's a square root function. Is it translated to the right or the left? Left 2. Looks something like that. Clearly 1 to 1, right? So f is 1 to 1. Okay, so to save some time, I'm not going to write out all that other stuff we're supposed to. We're supposed to say it's 1 to 1 because it passes the horizontal line test. Therefore, it has an inverse function. So hopefully we know that. Now on a test, will you have to? Yes. Yes. It's just a sketch. As long as you have the right, as long as you have the basic idea of the graph. But it really doesn't. I mean, it's going to get to, right, it's going to get to infinity eventually. All right. So now let's solve this for x. So tell me what to do. Square both sides. Good. And what happens when you square a square root? Square root goes away. Then what? Subtract 2. And done, right? So, but if we could leave it like this, it makes so much more sense because what that means is if you plug in the y value from the original function, you get the x value of the original function. So our final answer, though, is f inverse of x is x squared minus 2. But we know that cannot be correct. It can't be. Because we know that the reflection of the original curve, if we reflect the original curve into y equals x, we get the inverse function, don't we? Are we going to get a full parabola when I flip that? No. You're going to get half of one. Because like this point is at negative 2, 0. When I reflect it in y equals x, or if I do the inverse function, it's going to become 0, negative 2, right? It's not going to look like that whole parabola. So we've got to look at, well, what's going on then? I mean, we can see graphically that we're not going to get the whole parabola. What side do you think you're going to get? The right half, right? You're going to get the right half. But let's look at y. So there's something about inverse functions that we have not talked about, and we have to talk about that now because we didn't need to until this point. So here's what's going to happen. When I looked at my original function, let's look at its domain and range. Okay, how do you find the domain of a square root function? We set it greater than or equal to 0. We get x is greater than or equal to negative 2. That's why it started right there, correct? Okay, so it's going to be bracket negative 2 to infinity. Well, what's the range of the y values for that graph? Here's the y-axis. What's the range of the y values? Right, because you do how low, how high? On this y-axis, this is the lowest it goes. That's 0. How high it goes to infinity. So our range is y. Now here's what... Right, we haven't done the inverse graph now. Now we're going to talk about the inverse graph. Okay, so I'm going to do the inverse graph, and I'm just going to plot a couple points so you can kind of see why it's the right half. So I'm going to plot a couple more points in the original graph. Like I'm going to do right here, that will be 0, square root of 2. Square root of 2 is like 1.2, 1.3, 1.4. So if I switch the x and the y, it's going to be over here somewhere. Okay. Make sense? Okay. If I plugged 2 into the original function, I would get 2 comma 2. Well, guess what? When you switch that on the inverse, I'm going to do the inverse in red so it shows up better. It's going to go through here. And I could keep on going and keep on going, and it would look like it. There. Now, here is where you got to know a couple things. But if you think about it, it makes sense. Right? What is the range of the red graph? The range of y values? Infinity. Because it's going to keep on going. What's the domain of that red graph? Because see, here is, if you look on the x-axis, domain's x, right? So 0 to infinity. Do you notice that obvious pattern? They switched, didn't they? And if you think about it, it makes sense. We switch x and y to do an inverse function, right? So it should make sense that the domain and range switches. So what we learn is that the domain of f is the range of the inverse function, and then the range of the original function is the domain of the inverse function. This is one of the reasons why we had to do domain and range in the first place. Because if you didn't know how to do domain and range, you couldn't give me the answer to questions like this one. So, what we do, because going back to the algebra we did, right here I've got f inverse of x is x squared minus 2. Okay, that we know that's wrong. So what we do, you do the domain and range of the original, and I know that the range of the function is the domain of the inverse function. So what you do is beside the problem, you write the domain, and then that tells you I'm only going to do the right half of the graph. Or, using the notation in the back of the book, they will say it's x squared minus 2, comma, x is bigger than 0. And here again, this is not easy. This is the most difficult problem. It's going to take more than 10 minutes for you to get this. So that's why, you're going to see it again tomorrow. We'll do another, I've got time to do one more today, and I'm going to do another one tomorrow to make sure you got it. But this about... Okay, the answer is this. One or the other. You give me one or the other. Okay? That's just scratch work to get the answer. Okay. Okay, let's do one more. I got time to do one more. Uh-huh. If, well, it really is if then. If you have the domain of if, then you have the range of the inverse. Okay, now we're going to go backwards. Let's say I tell you that you have x minus 5 squared when x is less than or equal to 5. Okay, so let's think about what that means first of all. First of all, that's a parabola, right? How's it translated? To the right. Something like this, right? Now that is x minus 5 squared. That's not what we're looking at. Why? No, why? Because it's not 1, 2, 1. So that's why they give you what I call this domain restriction. This is telling you I'm only looking at part of the graph. And normally you're either looking at the right half or the left half. No, because that's not our problem. Our problem is we're either going to look at the right half or the left half. So if it's got x is less than or equal to 5, what is that? We're looking at the left half. So all we're looking at is this part. So that's what we're looking at. And clearly that is 1 to 1. All right, so now we find the inverse function. So that's where we replace f of x with y. We have to solve for x. So how am I going to solve that for x? Nope. Okay. What's wrong with that? Sure it can. Something else is wrong with that. That's not plus or minus, something y'all keep forgetting to put. When you do the square root of both sides, you have to do plus or minus, always. Then move the negative 5 over. When you're doing the square root of both sides, you should always put plus or minus. Yes. So, really, f inverse of y is plus or minus square root of y plus 5, or changing it to x, we get this right here. I would show the work. Okay. Now we know we can't have two answers because you've got a positive answer and a negative answer. You should know that can't be right. So you've got to decide, okay, is this the answer or is this the answer? And then here's where domain and range comes into play. All right. So over here in the problem, they told you that the domain was negative infinity to 5, right? Isn't that what x is less than 5 is? Right? What is the range of that? 0 to infinity, right? Because there's the lowest on the y, and it's going up. So guess what happens when I go down to the inverse function? It switches. the range becomes the domain. If you think about it, that makes sense. Because I've got square roots, right? We already know that. We know since I've got square root functions, I should know that I can only do 0 to infinity. So duh, that doesn't help me. The range is what helps you. The domain up here becomes the range down here. So think for a second. I've got to pick the one where it's going to give me y values from negative infinity to 5. Give me 10, 20 more seconds. So think about it. If you plugged in some values into this one, you're going to get like 6 and 7, right? And it can't be bigger than 5, so you know that one doesn't work. But see, if you plugged values into this one, you would get numbers less than 5. Like if I plugged 1 in there, I'd get negative 1 plus 5 is 4. If I plug, 4 in there, I'd get negative 2 plus 5 is 3. Okay? So this is the one you pick. So I'm not going to lie and say it's easy, guys.